Before we get started with this episode, I want to point out two things. The first one is that we are aware of the physics of putting weight behind the rear axle and high up. We know that it is not ideal, but we think that it will be within the parameters, within the limits, and we think it will be fine. The second thing I want to point out is that we're also aware of that a lifting device and a pulling device are two totally different devices and require totally different safety parameters. We are going to use a winch, i.e. a pulling device, to do lifting. We're aware of the restrictions and we are going to make it as safe as possible. With these 2 points now clarified, I hope you enjoy the video. Hello there! Long time no talk. A lot of things have happened here in the fabric cobbler's paradise, but not anything of it has really been filmable or even YouTubeable. Today, on the other hand, I'm gonna try to tell you a little bit of a story about what's happening and why you haven't seen any of that stuff. The project that I'm sort of working on right now wasn't meant to have any work done right now or something like that. This whole part of the project has always been part of the bigger project, and in earnest we started doing the proper research of this probably 9 months ago, and it started to lead to some fruit at the end of 2022. It took us many months to find the products that we wanted and a supplier. And the supplier has been absolutely superb. And that is until the delivery yesterday, the 23rd of January 2023. You see, we placed an order just before Christmas, and because of lead times and other self-imposed bureaucratic factors, yesterday was the delivery date. And we thought we ordered one thing, and they thought we ordered another thing. So now we have some extra work to do, and I'm not happy about that. So let's see if we can turn this slight screw up to a non-issue. Let me explain. This here is a very special bearing. It rotates this way, and there's another bearing here that rotates that way. This is a forklift mast bearing. It is designed for linear motions and very much force. This is a very expensive bearing, and when with this anti-corrosion coating, it's even more expensive. However, there's a problem with this, and that is that the bearing is attached to this plate. This plate we thought was an optional accessory, and we didn't specify this, but after we realized the problem, we contacted the seller, and the company said that that's usually how they ship, and they agreed that we never actually specified this, and now we have it. Which means that these very heavy plates have traveled far. There has been tax paid on them, there's been shipping paid on them, and we have a honking big weld in there that I'm now going to try to remove. Luckily, we bought this tool. That's a mag drill, and we bought it primarily because we knew we needed to drill 12 35mm holes in some 8 to 10mm thick steel. That means that I'm now going to try to use the mag drill to drill out the weld here, and we already got out here in the morning to see if we could find a solution to this, or if we needed to send all of these back and exercise another 3 weeks of lead time. So let's see how that goes, but before I start screwing around with that, I'll show you what they look like. So here's one of the cool parts with them. These bearings are dismantleable. There's two screws on here, and you take those off, and the bearing comes off, and the other bearing comes off, and there's a space for a grease nipple in there. So there's a grub screw in there that Kaz has kindly fully sunk in there, So now all I have to do is put a bit of tape over this place here where the grease is supposed to come out, and hopefully I can mount this dismantled bearing into the vise and use the spinny knives there to see if we can get this out. So, wish me luck. Remember, children, always use protection. I took the handles off the mag drill and replaced them with some shorter, more rough, more universal handles, so I can spin to drill down or push to drill down whilst it's in this confined location. So let's see. Should be. Question is, do we want to punch it out? For the next one, we need to improve that this doesn't bend, that I don't hit my thumb, and that I don't hit this in the ground like crazy. Okay, second attempt. What we've learned is that hitting your thumb still hurts after many years of practice, and I have also put these metal plates on top of here that are held in place with these little clamps, and then I used the one that I cut off right now just before, and I put these bigger plates on here so that I can use this one to make sure that the jaws are pinching it in unison. And I have also made some measurements, and I put a piece of tape on the back here because we're out of scale on this thing, so that I now know sort of how far I need to drill from this surface. And with that, let's see what happens. Engage old man glasses. Engage it. With firing related and so. Okay, it's gone. No. That was more successful than the previous one. After doing the two test ones, I figured out a little bit of a manufacturing process here, and apart from spending a lot of time and being frustrated, the end result was quite good. Keep in mind that I also had to do more than just drill them out. There's still a lot of cleaning up that needs to be done. If you watched my videos before, you know that I like to put things on the scales to see what the actual scientific result is of the things that I do. So in this case, I couldn't resist putting the plates and the bearings on the scales, and the end result is that each of those plates is 900 grams, which means that we removed 10.8 kilos, and in the channel metrics, that's 20 beers. Anyway, needed to do the rest of them, so just keep on keeping on and getting those plates removed. Okay, boys and girls, it looks like I have run out of excuses, so I finally have to start building this contraption. We have the rails, we have the bearings separated from their stupid plates. And yesterday we got a delivery of steel. This here is a 120mm wide, 12mm thick piece of bar. And then we also got a 50 by 30 and another 40 by 40. That kind of means that it's time to fabricate. This is the drawing that I've made from the CAD thingy. And it is very simple. This is the plate made out of this that is going to be attached on the back of the truck. So I need 4 of those, so that's going to be the first organic step. Now, if my memory serves, one of the plates is going to go there and the other one's going to go up there somewhere. Because I need to use the mag drill to drill the 35mm hole for the bearing, I want to keep the plates as long as possible attached to the big bar. That way I can stick the magnet onto the big bar piece. The simplest thing would be to cut 4 pieces of this. That would make it a bit more difficult, as I have to clamp the bar to the table and the mag drill would be on a table and stuff like that. So I'm going to do them one by one, point being leave the piece of material as large as possible for the mag drill base to attach to. As this is the last one, the 4th one that I am making, I've kind of figured it out now, so I thought I'd talk you through the important dimensions of this. Technically, what's important is this distance here, and that this is centered here. So when you look at the plate like this, this line is important because that will be the center of the bearing. And then the distance from either here or here to here is important. So that's the 112 millimeters. Once this is ground down to the line, I can then put the clamp it to the back of this, because this is the 40 millimeter that the material thickness is that is going to be welded onto. The rest doesn't really matter. That means that I can mark where the center of the bearing should go on the truck, and I don't have to worry if this edge or this edge is out of spec. Let me show how I mark it up. The first thing I do is I get the full dimension of it here it's specified as 149.5, so I'll do 150 because it's easier and it's probably good to have more margin than less. And the easiest way to do that is to make sure that the square is up to the edge there, and then just simply push the ruler against there. Make sure that the ruler is square too. So that's 151 now. And then I need to scribe this fairly deeply, and obviously one of the problems with scribing deeply is that you might score it next to each other, that the scribes might not be exactly on top of each other. And the reason why I want to do this deeply is because I will probably end up grinding the surface here for welding. And the next line I want to do is the 40 millimeters away from there, and that one can be easily done with using the fireball tool blocks. So again, if I push the square up against the edge, I can then put the tip of the scribe into there, and now I can slide that up to there. So now I should have a 40 millimeter thing here. And then if this is now an awkward position for me, so if I can just get one spot like that, and I can put the tip of the scribe into that ditch there, and I can do this part again. It's going to be the upright, goes like so. Now the next one I need to do is the center line, and it's because of the edges of this are a bit round, this can't be super exact, but like I said, the most important thing is that the hole is on the center line, and the center line goes all the way to the back here. The easiest way to do this is just with this device, and if I do it from both sides, I'll get an average. So in the center of that line there is where the line needs to go. Try to get it exactly in there. Put that up to there, move the ruler over the edge there, and then carefully push down. There we go. And the next one that we need to do is the distance from the back, or that one if you want to the center of the bearing hole, which is 112. So there you go. And then by sliding the center punch in the groove, I know that it's in the groove, and then I need to look at that, and then I just double check that it is actually centered. It isn't really, so let's punch it to the side of it. So now it's pretty much spot on there. So now when I have that, I'll take my compass and I'll double check that this is correct here. Yeah, good. And then line from here to the tangent of that one. There, I'll do the same thing again. Scratch off the scale, mill scale. And the reason why I do it all the way to the edge is because I'm going to cut it this way too. Same procedure here. There, do this. I'm just going to freehand the circle. Again, this doesn't actually matter, but it'll look better. I want stuff to look nice. There we go. Let's make a hole there. Because the Makita metal cutting circular saw isn't that exact, I still have to grind the plates to the edges here, and I try to grind it so that the top edge is a little bit further in than the bottom edge. That means that when I put it on the sander, I don't have too much to actually grind. Ideally, I'd have one of those super duper awesome mega belt sanders, and I'd just put the plates on there and I could get them nice and square. On the actual disc sander, it's not very accurate, so I need to basically true it up and make sure that it's square every time I use it. Also, I haven't found any very good sanding paper for it, so I feel that the paper just, the grit just disappears, and then you just end up pushing the workpiece into the sandpaper, and it doesn't actually do anything apart from heating it up. But this system works quite well. It's a little bit tedious, so basically get the bulk off with the metal cutting circular saw and then grind the edges as well as you can with the grinders, and that actually works really well. But to get them nice, crisp and actually 90 degree, then the disc sander is the thing to use. As you can see, we now have 4 plates that are ground to shape and dimension. These 2 match and these 2 match-ish. So I've marked them so that I can keep them on the same side. It doesn't really matter, I think, because there's already a big discrepancy in the bearing size and the rail dimension. So I think there's about a 1 millimeter gap in there already, or even more. So if these are half a millimeter or a millimeter out, it shouldn't make a big difference anyway. However, I'm sitting here contemplating whether I should put speed holes in, and I think that I shouldn't, which is a shame because I like speed holes and speed holes are awesome. But yeah, let's focus on getting this done instead. And that means that the next thing I want to do is I want to chamfer the edges and remove the mill scale. Removing the mill scales means that I need to redo the lines, and then I also need to do a line on the back side, and that is so that I can position the bearing, clock it the correct way. The plates are now nice and shiny. They have a bit of a chamfer on them. The next thing I need to do is I need to clean up this bottom or the stump or the axle or the hub. So I need to clean that up. But I think that's as far as I'm going to leave it today. I am covered in the metal dust, so I want to start the next day with some welding, and then if these are welded in, easy peasy lemon squeezy, then we can probably also weld them straight onto the truck. Okay, boys and girls, a little time has elapsed since the last video clip, but the point stands. We need to weld the hubs into the plates. But before we can do that, I think it would be best to fix the plates so that they fit. You see, whilst you were doing other stuff, we came out here and we scribed on these posts where the plates are going to go, and at the bottom ones the plates interfere just slightly with this. They need to be some 2 to 3 millimeters lower to match the scribe line. Very long-winded way to say grinding. The lower plates now fit onto the truck, as does the upper ones, because they didn't need modifying at all. That means that I am now completely without excuses to not proceed with welding these hubs to the plates. And I'm quite nervous because My relationship with Spatamaster 5000 isn't the best, and unfortunately a new welder isn't on the cards, but in life you play the cards that you're given. I'm going to try to make good friends with Mr. Spatamaster 5000 there, and we're going to try to burn, that's what the cool kids say, burn these in now, and hopefully it all goes well. It'll be fine. The first pair was welded in quite well. I'm quite pleased with that. Even Spatamaster 5000 in the back there deserves a little bit of extra credit. Apart from welding it in, a bit of grinding to make sure that it's flat. I don't know why that matters, but it just feels better that way. And then I used the angry end to sand the area of the grease nipple. No laughing in the back there, boys. So now those are okay-ish. So without further mumbling and talking, let's do the other pair. Cass has ground the paint off and I've clamped the driver's side bearing brackets onto place. It's time for Spatamaster 5000 to make another fantastic appearance. Okay, boys and girls, welcome back to the circus. In the last session we welded the plates on, as you probably saw, and that means that the next thing we need to do is we need to get the bearings onto the hubs, and then we need to get these rails onto the back of the truck there, clamped and positioned, so that I can weld in a piece of this in between them. That gives us the spacing and hopefully some form of rigidity, enough so I can lift it in here and continue the work on it. The rails need to be connected together so that they run parallel, but that's kind of all that they need to do. There won't be any direct forces on them. Apart from that, the bearings need to live in the grooves. We won't be lifting on the actual rails or attaching anything like that to them. But we'll see how that develops. The plans are minimal. Unlike normal, we do have a little bit of plans for this one. Now I need to mark the position of the cross members. The rails have been scribed, both of them. They have had the mill scale removed. The bearings are attached to the hubs and it looks really sweet. I've put some stoppers up there so that we can index the height of the rails. We got a little string there that we have hopefully tied well enough to the beam. We have some clamps here that I think will work by simply clamping onto the bearing, and that's our plan. Let's see how it goes. We have no idea what's going to happen. Hopefully we're not going to kill ourselves or break ourselves or anything else. So wish us good luck now. Down in the doobly-doo comment thingy and all that stuff that you have to do on YouTube. Anyway, let's get on with this and see how it happens. Well, that turned out quite well. Apparently it's a good idea to keep the ratchet strap on the side there. It keeps a bit of tension on the strap and pushes it upwards. There's now two very sturdy clamps on each of the bearings, pushing it outwards and into the bearing, so it's registered that way. The ratchet strap, as I told you, registers it upwards. And then there's a few extra clamps on there, just if one of them should fail. There's 3 spare ones there, so I think that's pretty safe, which means that I'm now going to proceed to try to put some cross members on there. Right, lads and lassies, the ends now look like that. So there's a stop there that should fit in between the rails, so it actually does, and that thinner thing goes out on the back, and there's a top one and a bottom one, as you have seen, and that means that they now need to go there, and we already marked the uprights, so we need to double check that they are registered up at the top, that they're clamped properly, and then clamp these in place, and then double triple check everything like that, and then weld them together. Totally logical, very easy, very fast, very good. Well, that goes in the video.
No, it doesn't go.
Yeah.
You weren't filming at that point.
Still filming.
Whoopsie.
Alright, the tack welding, if you can call fairly beefy welding tack welding, went okay. And now we've rigged up a little of a block and tackle thingy up there, and now we are going to see if this actually works. And by works I mean if it slides up and down, we're onto a winner. If it gets stuck there, then not a winner. So next thing is just to remove all the clamps and stuffs and see if it falls down or cracks or something like that. Let's give it a go. Another beautiful day here in the cabin of chaos. We have a patient there on the operating table, and the job at hand today is to embrace it, or maybe just brace it. It's probably a little bit too big to embrace. I think just a cross would be sufficient, and then also it needs to be fully welded, and these big gaps here need to be covered. Nothing too exciting, so without further waffling, let's get working. I've cut 4 pieces of flat bar like that, and the idea is that they kind of go into here, something like that, and sit in there. Because I hate grinding, I think I'm going to try to at least weld this bead here, that one there, maybe a little bit there too, with the TIG welder. That way I don't have to interfere too much with that surface and grind stuff and things like that. I've only done 1 of these so far. Currently they kind of look like that, and there's that lip sticking up there, and whilst that's stickety-boo and all, but it means I have to grind that top bit off, so that's why I have cut this back a little bit. I basically cut it from there to about there, and that way the thingy goes further in and there's a little bit more space there. But enough explanation. Let's see if the TIG welding goes. Bzzzt. Nice, tickety-boo. As usual with TIG and thick metal, the end result looks quite good, even if what I did was not very good at all from a technical point of view. So now I'm going to weld that part there. Despite the mental blackout with me not turning on the gas for the MIG welder, that's pretty good. We can leave it at that. Let's try to replicate this 3 more times. These insides have now been welded, and that means I am now considering them done. What I'd like to do next is to brace this whole internal thingy a little bit so that we won't have racking. For the purpose, I think that this is actually enough. These bars only need to keep these rails in parallel. We're not going to put lifting forces onto these or anything like that, so they should be okay. But mentally, I don't think it's good enough. Now, a drawback of bracing this is that I am also preventing access through if needed for some reason. That part of me doesn't like the bracing. As usual, this is a huge compromise with various factors. So I'm probably going to have a little bit of a think. For example, it would probably be easier to attach the bracing to the crossbars rather than to the rails. But then the only thing that holds on to the rails is where the crossbars meet. It is the rails that we are trying to actually stabilize. So yeah, I don't really know which way I should go about this. I'm sure I'll figure something out. As you can probably see here behind me, we decided to go with an A brace. That's the highest quality, highest level brace you can get. The other ones are B and so forth. We think this is good enough. It saves a little bit of weight on an X brace and it isn't as invasive in the center. It'll probably be just fine. The thing I need to do next is to clean up the areas where I'm going to weld and clamp it in place.
I've spent the last hour or so cleaning up and grinding up the welds, and it looks really, 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 really good.
That's where we ended up last night of working. The frame is now sort of technically okay. There's obviously tons of refinements that need to be done, but before we continue with anything else, we want to try to actually trial fit it back onto the truck to make sure that any screw ups we make in the future are not impacted by this screw up. The test lift has gone well. We are now in the process of lowering the whole contraption. Before we lower it, I thought this was a great opportunity to explain why this has to be so complicated. From the top bearing plate to the bottom bearing plate, that distance is important for the stability of this when it moves back and forth and side to side. The longer that distance is, the more stable this can be. Ideally, you could potentially just have two bearings really close to each other from a mechanical movement point of view, but from a stability point of view, that doesn't work. So this is the rails in their lowest position. That means that the top bearing up there is now barely touching in the rail there, barely in the groove of the rail. And this is the distance now that we have been able to lower it. So the second platform then has the job of lowering the last bit. Now keep in mind that these are 180 centimeters tall, and the rear wall is about 190 centimeters tall, and this is about 150 centimeters down to the ground. So if we do the maths there, we would have 30 centimeter overlap if we had just one platform that moves up and down rather than this two-part double slider design. I hope that makes sense. It took me a little while to figure this out. Thanks to Kaz engineer over there, it's worked out quite well. Anything to say?
It's hard work.
She probably thinks we should replace her with an electric winch in the future.
It's less grumpy.
Right. Let's lower the tone and the platform a bit. To both our surprise, we have 8 tabs, which is the exact correct number that we need. I did not think we could make those today. So thanks to Kaz for her effort, and yeah, productive day. On to the next one. Continuing on from last session where we made those little beauties right there, we now need to make something that goes into here, and what's going to go in there is that 40 by 40 box section there. That means that my first task of the day is to cut and chamfer 2 of those to 180 centimeters long and 45-degree chamfers on the end. So let's get on with that. What you see me doing here is mark and cut the 45-degree miters. I first mark the longest side, and then I use my 3D printed angle squares to mark the 2 sides. I then mark the final side, and when I cut them, I cut the 45-degree angles first, and I cut them a little bit deeper so I get a good datum to cut the flat spots also at a 45-degree angle. This gives me a very accurate miter. And as you can see, now we have these 2 uprights cut, and they have the appropriate angles at the end there. Just a side note, I find that cutting them with the angle grinder after marking all 4 sides a lot easier and more accurate than using my bandsaw. The bandsaw still needs some adjustments because it's a cheapo one, so it's not very accurate. And then I need to use the disc sander, and that's very difficult with 1.8 meter long pieces of metal. The accuracy isn't there when you're waving them around. I need to now mark out where all of these go. So that means that I need 4 lines on each of the sticks for 4 tabs. Let's get on with that. Before I can mark out the location for the bearing plate tabs, I need to make sure that I have the 2 uprights orientated in the right direction. I don't want to get these wrongs, you know, they are mitered, so they do go on the correct side. And once I have that figured out, I'm using the 2 Fireball tool minion squares as an end stop. This ensures that I have both of the uprights at the same location. So when I scribe, I can scribe across them, and that way I know that the scribe marks are at the same position on both of the rails. The exact location where they are lengthwise isn't that important. It's more important that they are at the same location. The sticks are now marked up, which is all tickety-boo. Before I can start welding, I want to get rid of the mill scale on the tabs and also clean up the surface on the bars. This is stuff that happens in real life, very seldomly on YouTube. Tabs are clean, rails are cleaned. I have also measured the distance in that thing there between my fingertips. It's not as accurate as I would want it to be, but then again, there's about 2 millimeter gap between the bearing and the rails anyway, so it looks like I will have to do at least 2 weld clamping situations per stick, and that is not taking into account welding from the other side. I wanted to get them properly welded in place from this side, almost properly, and then I'll flip them over and weld the long bead on the other side. Okay, tabs are now welded, or at least welded as much as I can at the moment without before I can weld the hubs in. And Spattermaster made us proud, so it went really well. But now it's time for the rotary eraser, and let's level these welds down so that it'll look pretty and it won't protrude. Okay, boys and girls, the tabs are now welded onto the uprights, and that means that we now need to weld the hubs in. So without further mumbling and waffling, I'm going to clamp hubs into place and give them some welds. when we finished in the last session, we kind of ran out of time and energy. That means that the next thing I need to do is clean up the backs of these tabs where I welded in the hubs. There's a lot of spatter there, but most importantly, the weld bead has come a bit too close to the grease nipple hole. Oh, come on, stop giggling in the back there. Anyway, so I need to make sure that that area is flat, and my OCD also probably want to tidy up the welds a little bit, even though the Spatter Master did us very proud again. So, well done, Spatter Master 5000. Let's get on with it. Okay, boys and girls, this is what it looks like now, and you can see the threaded hole there. That's where the grease nipple's gonna go. The way I found that I could actually enlarge the flat area was to use the angry end with the flat bit, so I can actually use it as a little bit of a imprecise milling machine. Unfortunately, that's all we have time for in this episode. Fear not though, the next episode is already pretty much done, so it will be showing up in a YouTube channel near you very soon. I hope to see you then, and thanks for watching.